So let's say I'm doing a chemical reaction, as I often do because I'm a chemist and we like to do chemical reactions. And it's a formation reaction, so I'm taking these two reactants and I'm forming this product. You notice this reactant is diatomic, this one's monatomic, and the reaction is balanced. In my product, I have one blue block. In my reactant, I have one blue block. In my product, I have two of the white blocks. In my reactant, I have two of the white blocks. So each of these things is an atom, right? And then putting them together to make a larger molecule. Now we could write in the balancing, the coefficients. There's 1, 1, and 1, right, that we're showing here, one molecule each. And so let's say I have this problem. I've got 24 grams of this reactant, and I want to know if I react away all 24 grams of this reactant, what kind of mass of product am I going to get? So we'll assume that we've got enough of this reactant to react away all of the blue blocks. How much am I going to get here? Well, the law of conservation of mass says that mass has got to be conserved. So the total mass that I have on the reactant side will have to equal the total mass on the product side. But I don't know what mass of this I'm dealing with, and I don't really need to know that to answer the question. As long as I know what a mole of this reactant weighs and what a mole of this reactant weighs. So each one of my blocks here represents a mole of that entity. So 6.02 times 10 to the power of 23 molecule. And because a mole is a counting number, it doesn't depend on the mass of that thing. A mole is just a mole, right? I can count up a mole of that thing. So for my blue blocks here, a mole has got a mass of 12 grams. And that's been figured out experimentally for me before. I can find that on my periodic table. So 1 mole is equal to 12 grams here. And I need to know what a mole of this stuff equals to, right? Because even though the mass of the blue blocks is not going to be the same as the mass that's going to end up over here, what is going to be true is that for every 1 mole of blue blocks that reacts away, we're going to make 1 mole of product, right? Because there's 1 of these guys going into 1 of these guys. So if I use 3,000 of these, I'm going to make 3,000 of these. So what I need to figure out is how many moles of my reactant are going to react away. So that's going to be my first step. I'm starting with the mass that I have here, and I need to figure out how many moles of this reactant does that represent. Then I need to figure out how many moles of my product will form. And once I know how many moles of my product will form, then I can figure out what mass that represents for the product, as long as I know the molar mass, which I do. There are 32 plus another 12, so 44 grams in every mole of product. So that means that there are 3 steps that I have to do here. First, I need to turn these grams of my reactant into moles of reactant. 2, I have to turn my moles of my reactant into my moles of product, figure out how many of each there would be. And then 3, I need to turn my moles of product into grams of product, figure out what mass of product would that number of moles represent. So let's do those steps. Step number 1. If I want to go from grams to moles, I can either do that step using unit canceling, unit analysis, or I can do it with my molar mass formula. And I'll do it with the molar mass formula. So I know that my number of moles is equal to my mass divided by my molar mass. And my molar mass here is 12 grams in a mole, right? 1 block is representing a mole, and that's got a mass of 12 grams. So to find the number of moles here, I need to take my mass divided by my molar mass. So the mass that I'm reacting is 24 grams, divided by my molar mass of 12 grams per mole. And 24 divided by 12 will give me 2 moles of, we'll call them blue blocks. So my 2 moles of blue are going to be present if I am reacting away 24 grams. Okay, well, if I've got 2 moles of blue, how many moles of product will that represent? Here I'm going to use the ratio of the number of moles of reactant to the number of moles of product, or really the number of moles of the thing that I know versus the thing that I'm trying to figure out something about. So this is my step 2 then. So I have 2 moles of my blue reactant. I'm trying to figure out how many moles of product are going to form. And this is where I look at my coefficients. Every time one of my reactant reacts away, it's going to produce 1 mole of product. And so you might already be able to see that if 2 moles of this react, it's going to form 2 moles of product. But let's show you how to do it mathematically, because it's not always going to be that easy. So units will cancel just like variables do. So if I have 2 moles of my blue reactant, that means I need to look at the mole ratio. There's going to be 1 mole of blue reactant that reacts away every time 1 mole of product is formed. And then I've got blue divided by blue, so those will cancel. And so what this will show me is mathematically I have to take 2 times 1 divided by 1, and then that's going to give me my moles of product, which 2 times 1 divided by 1 still, of course, equals 2. So there will be 2 moles of product that will be formed. And then finally, step 3, I need to take these moles of product and figure out what mass that represents. So here I can use my molar mass formula again, but now I'm looking for mass. So I need to rearrange this guy a little bit. So let's get little m by itself, multiply by big M on both sides. That will cancel and give me my mass is equal to my molar mass times my number of moles. Now my molar mass here was 16 plus 16 plus 12. So 32 plus another 12 would be 44 grams in 1 mole, right? Because this is representing 1 mole of my entity. And my number of moles that's reacting here is 2. So 44 grams per mole times 2 moles will give me 88 grams. So if I react 24 grams of my reactant, that's going to produce 88 grams of product.